What's going on, guys? Kotax here. Today, here with a different type of video. Today I want to cover exponent laws. So I want to start doing math and physics videos as well on Kotax, just to expand anyone who can come to Kotax and really just expand this brand and just continue the mission of just pushing free education simplified. So today we're going to cover exponent laws. So I'm going to try to make this as quick as possible and see what works well for this video, and then we'll try to optimize as we go. So the first exponent law I want to cover is when you're multiplying two numbers that are the same but with different exponents. So here we have both base a. So first what you should know about exponents before I even get started. So if I have a base and I have an exponent. So we have two parts of each exponent, kind of. So the first is the exponent, and then that's not the exponent, sorry. The first part is the base, and the second part is the exponent. So now you know what I'm talking about when I refer to base and exponent. So here we have same base, different exponents. So what we can do is just do a, and then we can kind of add the exponents at the top. So an example of this would be something like if I had 3 to the power of 2 times 3 to the power of 3, that's basically equal to 3 to the power of 5. So that's our first exponent rule. Then we'll be doing some questions later just to kind of work on that. So the next exponent rule I want to show you is if you have different bases multiplied together and they're put to the power x, for example, this basically dumbs down to a to the power of x times b to the power of x. And this exponent distributes into both of these bases. So an example of this could be 3 times 2 to the power of 5. And that distributes to 3 to the 5 times 2 to the 5. So that's perfect. So, and I think this will be our last rule for today. If we have the same base, but different exponents in something that looks like this, what do we do here? Sorry, we want same base here. So let me write same base. So this basically can turn into something that looks like this, a to the numerator minus denominator. So just remember that. That can be really helpful for you. So an example of this would be, for example, if I have 3 to the power of 6 over 3 to the power of 5. So this is example 3. This will basically be equal to 3 to the 6 minus 5, which is 3 to the 1, which equals 3. So yes, those are our examples for today. Now I found these questions from Nelson Math textbook for grade 9 students. So let's go through some of them and see how we can easily solve them using exponent rules. So again, I'm going to try to make these videos as quick as possible and hopefully they help. So here we have 30 to the power of 40 times 40 to the power of 30. So the question is, what is the number of zeros at the end? So basically what we can do is we understand 3 times 10 is 30 to the power of 40, and 4 times 10 is equal to 40. So when we make zeros, what is 0 basically? So let's just kind of sidetrack a little bit over here. And let's make like a little note to the side, rough notes. So when we have 10 to the power of 0, that's 1. If we have 10 to the power of 1, that's 1 0. So notice how this dictates the number of zeros. So we can kind of almost make a separate note here and say that's the number of zeros. And we can kind of continue this pattern just so you guys can see how this is working. So you see 2 zeros, 2 zeros, 3 zeros, 3 zeros. So we understand the zeros are coming from 10. So we can use our exponent rules and kind of solve this. So this can distribute, so we can kind of draw some arrows here so we can see what's going on. So we have 3 to the power of 10 times 10 to the power of 40 times 4 to the power of 30 times 10 to the power of 30. Okay, and you should notice that this belongs to this, and this belongs to this. Okay? Simple stuff. Great job, guys. You guys are doing great. So look, multiplication is commutative. What that means is A times B equals B times A. So we can rearrange this in whichever way we want. So strategically, I want this to be, so 40, 3 times 40, 4 times 30. And let's just make this multiplication sign to say consistent. Okay, perfect. So, now what can we do? We can kind of ignore this because we know no zeros are coming from here. So we know zeros are coming, that was ugly, coming from here. So we can basically see that we have a very cool exponent rule happening right here. So our 10 to the 40 is a blue and 10 to the 30 is a red. So we can combine these two using our exponent rule 1, I believe. And using exponent rule 1, we can see that we have 3 times 40, 3 to the power of 40 times 4 to the power of 30 times 10 to the power of 70, because we do 40 plus 30. 40 plus 30 equals 70. And we can see that the answer should be 70. So if we scroll up, we will select option C, 70, and that's the right answer. So next, let's just do this. This is very easy. What's 6 times 6 times 6? So when I have 3 to the power of 2, that's equal to 3 times 3. If I have 10 to the power of 3, that's equal to 10 times 10 times 10, which is why it's equal to 1,000. So if I have 4 sixes, this should be 6 to the power of 4, because the base is 6 and the exponent x should essentially be the number of sixes. Cool stuff. Okay. So here, there's a few ways we can do this. So you could either do guess and check here, or I'll basically show you guys something called log rules. So log rules will allow us to do this so much quicker than traditional guess and check. So there's actually a few ways we can do this. I'll show you 2 methods we can do this. There's actually technically method 1 and 2 are essentially the same. But method 3 is the way that's kind of the pro way to do it. So let's leave the pro way for later. So we can just basically try each one. And we know 3 to the power of 3. So the first method is guess and check. Change the color of that to something purple. Second method is write 729 as a power of 3. And the last method is logs. And you're going to say, what do you mean logs? Let me show you. So I'm not going to explain logs completely, but I can show you how to kind of work these type of questions. So the first method, guess and check, is kind of tough because 3 to the power of 3, 27. And you keep checking, and then, you're going to realize, sorry, I'm just figuring out my calculator right now. 3 to the, okay, right there. 3 to the power I'm just going to figure out the right answer. So guess and check tells me I think it should be 3 to the power of 6. Yeah. So 3 to the power of 6 equals 729. And great job. So now the other way you can do this is essentially say 3 to the x equals to 729. 729 is 3 to the power of 6. So 3x equals 3 to the power of 6. That means x must equal 6 because the base is the same. So the exponent must also be the same. Because when we look at an exponential curve, it's something like this. And when it's something like this, each kind of base will correspond to only one possible y value. And the last way to do it is logs. So with log rules, this is kind of cheating, and feel free to end the video here, but if you're wondering about logs, I'll just quickly do a rundown. I won't give an explanation on how they work, but what you can do is 3x equals 729, and you can take the log of each side, and this will be, you can take log base anything, really. And if you take log base 3, you skip a step, but I think most calculators don't really allow that. And using log rules, you can take the x out, and kind of, I guess if you guys are doing your homework or something and you want to have these type of questions and you want to do a quicker way or possibly impress your teacher, you can use logs. And if you do log 729, and you can take out your calculators and really do this, and you'll be shocked how it works, even if you don't understand log rules completely. If you do log 729 divided by log 3, you'll get 6. And that's kind of a cool way to do this. And yeah, so I hope you enjoyed today's video, something a little new, something a little different. Let me know if you enjoy these types of videos, and I'll keep making more of them. Thank you very much for watching. Please like, comment, and subscribe. See you.